Let's talk about code sharing between iOS and Vapor. And let's talk about stories. First of all, I am Martin Lasek, and I am an iOS, Vapor, and game developer. I started with Swift basically with game development in 2014, and then went to Vapor, and then back to iOS game development, and now iOS normal application development. Like basically everything, and I'm doing all this kind of stuff alongside also on YouTube, Medium, and Instagram. So if you want to follow me off one of these platforms, you will either find me with Martin Lasek or Martin_Lasek. I'm like also doing tutorials on YouTube on Vapor and iOS, as well as on Medium, and very active on Instagram, and so you can catch me there. Right, so let's talk about enemies. Enemies of programmers. What is the enemy of a programmer? Like if we are on a daily basis and we code, what is it that we don't like? What is it in code that we don't like? Does any one of you have something that comes to your mind if you think of, oh well, for example, boilerplate, something like that? Do you have anything in mind that you don't like about coding, doing over and over again? All right, let's simplify that. So there are, of course, more than that, but this talk will also focus on code duplication, because if we have code duplication, this is more bug-prone, so we will more likely have bugs, as well as inconsistency if we have two places where we write basically the same code, and even if it's a different person doing that, so we have a more likeliness of inconsistency. So that's our enemy here. So we need a hero. Who of you knows the Legend of Zelda series? Who of you knows the series? 1, 2, 3, 4, 5, 6, 7. How many of you have I triggered right now? 1, 2, 3. Okay, let's fix that. Great. So we have a hero who wants to defeat it. Who wants to defeat the enemy of code duplication, bugs, and inconsistency, right? So what is our current situation? We have on the one side the API, as well as like if we think of an API without a user interface, we have just the API maybe communicating through JSON, right? But we also could have a website, either served by, when we talk about Vapor, either served by Vapor using Leaf, or could also be like Vue.js on the front end communicating with the API, and still through JSON. And we have two places where we write code. And on the backend side, right, what code do we write? We write, for example, models. We write error, endpoints, utilities even, and even more code. And all of that code, when we're communicating with through JSON and we are using a front end, let's say iOS app, then we basically need the same things on the iOS app as well, because we want to like query the database, map it through a model, do some stuff with it, maybe then map it to JSON to send it back to the iOS app, and then map it back from JSON to the model. And then we have like the duplication of model definition in iOS as well as in the backend side. Same goes with the error message. Let's say you want to display the error message on your website, and the same error message you want to display in your iOS app as well. And then you have like on two places where you display the same error messages. You might want to have one place where you define it. And so, like in an optimal world, you would have one place where you define all these kind of things and have it shared as a dependency in Vapor as well as in iOS. And the question is whether we can use or whether we can achieve that using SPM, right? Because in Vapor land, SPM is a bless, at least to me. And in iOS land, I have never touched Cocoa, pod or cartridge yet. And the first time I have, because I always found my way around doing everything myself, but now dealing with, for example, a dependency, I wanted to find out whether I can use SPM. And so let's have live coding. Let's build from scratch a super simple Vapor application, and then move our code that we are about to duplicate into a shared repository, and then build a super simple iOS app, and then let's see whether we can have actually one dependency defined on GitHub, and using SPM on both platforms to basically fetch that and use it. What can possibly go wrong with live coding? So, let's go here. I think I've spoiled you. So the first thing, I mean, it's if I'm talking too fast, you can just raise your hand. I'm trying to fit the time as well as like not bore you. So we are going to just define a new API and call it Hero API, right? And once that is done, we will go inside our Hero API and just open Xcode. Fetch our dependencies, open Xcode. Two of you have never seen Vapor in action like that. Have never seen Vapor in action. 1, 2, 3, at least. Can you still hear me? Loud and clear? Everyone up there as well? Very good. There's no one. And we are going to just wipe out the Vapor application and just have one root returning a JSON representation of a model. We're not doing any databases to keep it simple, but just so you get the idea. So let me also prepare a Google Chrome window over there, which is super bright. Let's do that. Okay, so we got our Vapor application, and let's, for simplicity's sake, wipe out everything we don't need. I just like doing that. I love it. It's such a nice feel. We don't need that. We don't need anything. And we don't need that either. So that basically runs. And let's build that once because it takes a little bit for the first time, right? And it should run on localhost 8080. It should come up. Can you read actually everything? Good? Yeah? Okay. Are you also awake now? Great. So let's have it run, and if the command line pops up, we will see that it is running on localhost 8080. What we are going to do is we will imitate, or we will define a struct representing a model in a second. Okay, so it's succeeded. I'm just waiting for the command line to pop up, otherwise we won't get any response. Oh, whoa, you're right. The wrong scheme. It has to be the wrong scheme. Luckily, it will be faster now. Popping up the command line. Now it's running. Okay, so no response, right? Okay, can you see that? I will just make that a little bit larger. Okay, let's define a hero struct, and let me just copy from here because of like simplicity. So we have a hero struct. We have to conform to content, right? In order to be able to return that hero struct, we have just a simple name, and we have a weapon for that hero, defining the weapon down here: sword, bow, and chicken. I mean, although Link was never able to use that chicken, it was very harmful for him. And so conforming to string encodable to also to be able to map to JSON. And so what we can do is just say request, router get, let's say hero, and return. So we got a request in here, and then return our hero called Link with the weapon of sword. Right? If we run that, that should just work out fine. And if we refresh, we see our hero, Link and sword in JSON. Let me just, now that code would be actually should be duplicated in the iOS app to be able to map back from JSON to your model to be able to work with it. So let's just create a new project to put that code inside. So that means, where are we? We are here. Okay, we are going to desktop. I'll just move this a little bit over here so you can basically see it. I think I haven't moved the Hero API to desktop. I actually like that. Yeah, we can close Xcode for that for now. Okay, we have the Hero API. Now we are going to create the Hero shared. Right? And we are going to, we're going inside Hero shared, and we are going to init a package.swift file. If we look at that, let me just make that a little bit more visible. We have a package.swift file. We will have to modify that in a way I haven't done that before, I haven't seen before, in order to have it work. So there are basically 3 things you would have to know about, and that is in package.swift, you would have to first of all, let me just check here. All right, did I make a mistake already? No, I didn't. That's all right. Yeah, the first thing you will have to do, I'm relying on 2 scripts. One script that would modify my shared project to be able to be used as a dependency as well in iOS land. And later on, I'm using another script, both is publicly available and downloadable by someone I will also name later on. The second script will modify your iOS project to be able to actually pick up the dependency. Just once, right? And afterwards, it will just work. So the first thing we are going to do is we have init the package, and we are going to install. Can you read that? Xcode project using sudo gem install. And I have installed it already, but I like to just perform the same thing you would do. And when that is done, we can curl or actually download the rake file, which is the first script. If we now look at this, we have a rake file. And if we look at rake file, I'll just shortly show you how it looks like. It's just this little, starting from here and here. It does some magic. It doesn't really matter what kind of magic. I mean, you can dig into it if you're a little bit paranoid or curious. But basically, what you want to do is then to use rake, and then since you've installed it, you've installed Xcode project, you can just say rake Xcode project. And let me just double check I'm doing that right. Yeah. And that will basically generate your Xcode project for your shared repository. So we got that. We need that later on. Basically, we need it now. We can now open our shared repository, our project, and put our code we want to have in one single place inside there, right? So let's have that project open and open our Hero API once again, where we have our Hero model, Hero API. Not on desktop, right? Hero API. All right, so we got this code here we want to have in our shared repository. Let's move it out here and move it into a file over here and call it, let's say, Hero. Hero, and delete that. Now, content is Vapor specific, and that's fine. I mean, we can just change that to codable because we know we need to conform to codable in order to be able to decode from JSON when we are in iOS land. Basically, whenever you're working with JSON and you want to map from or to, you would have to conform to codable. And what we can do later on here is fixing that to be still able to return that. But we will do that in a second. So we have our shared repository or a dependency right now with Hero, for example. But let's do one more thing and say we are defining also API routes in our shared repository. So we can use that to define on the server side the routes as well as using the roots on the iOS side to call the roots. So we have like one place and a type-safe routing. It only works to a certain extent, but it's for demonstration purpose. And what we have to do is as well, since this is a package, right? It has to be defined public because default is internal and it will not be available for anything that is actually pulling that package in. So that is a catch. So defining everything public, you want to have public. We can delete that default file. And same goes for API roots and then calling it, let's say, public static for hero. Right? Let's do it like that. Sorry? Thanks. All right. Got that public, that public. All right, so that is our package we want to share. So let's just create a repository on GitHub and push it to GitHub. It's over there, is it? Over here. New repository called Hero Shared. We can have it private, public, whatsoever, and basically just execute these commands. So git init, well, yeah, git everything add, git commit, first commit. I'm not going to write out that one. And then pushing it to the repository. So we got that now up on GitHub. But we're not done yet because we have just created a branch, but we haven't created a tag. And we are going to use a tag as a versioning system to define our dependency. So let's just create a tag and calling it the version 0.1.0. And then push that tag as well. And if we are updating, we see that we have our tag here, representing the current state of the project, which is having API root as well as hero. All right, now we can actually adjust we can close basically the API because Xcode doesn't like if you change code while it watches it. So what we can do is we can just modify, or we could have done it in Xcode basically, and then afterwards, let's do that, that's easier. So back open, and then in package.swift, let's define our new dependency, right? So basically, copy paste 01, the repository URL, copying that inside here. Also adding it as a target, hero shared it was, and that's it. Right? Dependency defined, that's normal for Vapor or for server-side, that just works. So I'm just using Vapor update, whoops, and a closed API so we don't encounter any errors, and it will just pull in the dependency as a package. That's basically also how you actually write your package, because I didn't know that before either. Like, how do I actually write my own package and define it as a dependency? Well, that's how you do it. So it will pull in the new dependency, it will open up Xcode, and we will be able to import it and use it in our roots.swift. So basically, hero is not available as long as we haven't imported hero shared. And we can see hero shared here already. I mean, I'm not sure whether you can read it, but I think, yeah, you might be able to read it. So hero shared is there, and if we haven't done anything wrong with the access level, internal and public, it should just still work. And let's build it and make sure this works. This is still the stuff that the most of you already know. We will go to the iOS fun part in a second. So initializer, god damn it, yeah, I forgot about that. So the initializer has to be public as well. So weapon, Luckily, this will not take as long. And let's just push that. Public init. And use another tag. Like that. And we can close that again. Not this one, but this one. And use a Vapor update. That's a good example of handling unexpected things. Sorry? Oh, you're right. No. I've used it from. Like it starts from 0, but you're right still. If you have defined it differently in package.swift, then you would have to update your tag in the definition of package.swift. But I have used like from 0.1, so that's why we have 0.2 in. And now if we run it, it fails. Because it's not conforming to content, and that's something you don't want to do in your shared package because it's very Vapor specific. And what you can do is just like basically just extending hero, conforming it to content, just like that, and then it works. Then it's just like Vapor specific stuff you don't need on iOS is done on the server side. Stuff you need on both sides you have in your shared package, and same goes for the iOS app. And now if we refresh, it still works. So that is awesome. Like this is just defining a dependency and adding it to your Vapor application. Let's do the same thing for API roots as well and call it hero. So we use that, right? It was still hero, so that works as well. That's awesome. And now to the interesting part. Let's create an iOS project. So first thing we are going to do is, I think it's just creating a new iOS project, exactly, and then, yep, all right. So simple new iOS project. Single view application, calling it hero iOS. How did I call it? Sorry? Did I call it? Yeah, I can call it hero app. I'm not sure. I don't want to call it like that. Okay, let's go for hero app. All right. So creating it, and let's just build it once. And what we are going to do is, I will just add a simple text label and a button. So then when we click on the button, we will implement a request to our server, and then using the response mapping. No, it's not working. It's working. Mapping it back to our model and overriding the text label with the name of it. So we see it actually works and is used. So we have a white screen here, right? Nothing fancy. And so we are going to, where's my code? Oh, it's down there. Okay. So we'll do it afterwards. We can we can now define in our iOS app our dependency using SPM and the second script I've mentioned. There are, of course, multiple ways to use a GitHub dependency, let's say, for your iOS project. This is not the only way, but this is the most convenient way I found, and I just want to present you that using these both scripts. So what we are going to do is in the directory of the hero app. Yeah, that was the thing, because it's API and app now. Hero app, we are going to create a dependency folder, dependencies folder. Go inside here, and also in it a package.swift file. Basically, we need that package.swift file and adjust that. Let's pull it out. Is it able to pull it out so you can see it better and bigger? We have to adjust that on 3 points. For that, let's remove the commands to have fewer code to basically skim through. All right. So the first thing we want to do is we want to add here another argument for type called dynamic. And yes, the dependency. Let's copy the URL out of GitHub. Hero shared, it was. put that in here in string notation, and starting from 0, 1. And then what we want to do as well is defining it here as hero shared, just as we are used to, right? So that thing is new, and we also have to remove the test target. Whoops, did I do anything wrong? Did I remove too much? Yeah. So let me double check I've done, yep, and then there is one more thing. We want to define as well a path here as another new parameter. So path at dot. So that's it. So you have dynamic type, this is normal, and then you have to also define, don't do that to me, the path. Let me double check. So that is updated, and that is updated, and that is updated. Cool. That's the package.swift file. And now we are going to use the second script. And I'm going to copy the file. So we have it here. We are going to use that in a second, but first of all, we want to Swift package update, basically pull down the dependency. Let's see if everything worked out fine. Yeah, perfect. So we are pulling in the dependency as that version. And now we should be able to say, again, rake Xcode project. That is exactly that. Okay, it created a dependency Xcode project. And this is the thing. We are now pulling, the only, let's say, manual, where's Finder? Manual thing we have to do is, let's go to the desktop, hero, app, dependency, and that one. In our iOS app, wherever that one is, of course the third one. No, it's not. Oh yeah, it was app, right? Because I didn't call it iOS. So confusing. So we are just pulling in, in our hero app, we have the dependency folder, right? We created the package.swift file, adjusted it, pulled in the dependency, and then executed the script to create the Xcode project. So we can now just drag that Xcode project in here. When we've done that, we select our hero app and define as an embedded binary from the dependency the hero shared framework. And let's see whether we can actually import hero shared and run the app without an error of library not defined. Yes, we can. So basically, we have pulled in the dependency and are now able to use that dependency in our iOS project. What I want to do is now simply simulate the communication between iOS and the backend, like the Vapor backend. And for that, I'm just going to set up a label and a button. You will see that in a second. It's not as complicated as it looked here. So let label is a new UI label, and button is a new UI button. So what I'm doing here is just like defining label and button. I have two functions that set up, that adds the label and have auto layout applied to position that label. The same applies to the button, having it positioned in the center of it. We don't have a target yet. I'm just calling then setup label and setup button. So basically centering it on the Y and X axis for the label, and having a larger font, and having the ... text, and for the button, centering it on the X axis and having it underneath of the label button, and then having a title for it and a color. So we just see that. If we click it, nothing happens. We haven't added a target yet. So we can do that by defining a function called request, because that's what I'm passing here as a selector. And here, we are going to use just a normal request. So we can just say, okay, we have a URL. We define that using a string, and that is basically, the base URL was HTTP localhost at port 8080, right? Plus API routes hero. So we are using the API routes already. I mean, it's room for improvement, but we're already using the shared package. And then we are defining a task, URL session, shared data task. Using that URL, we are force unwrapping here just for the sake of, I mean, sometimes it's okay. Don't laugh. It's just optional because if you are passing in invalid URL characters, then it would throw or return actually nil, not throw, but we are not passing in invalid characters. But still, you would not want to force unwrap. Anyway, so we are getting passed in here response, a data response and an error. And what we are going to do is we are using just data. So we are unwrapping data, else no data is found, no data. That will be interesting in a second. Is someone already triggered or not triggered, but I'm curious whether any one of you already will foresee the next little challenge. Gordlet. All right, so we have the data, and inside data will basically be our JSON. And we want to map that JSON using the shared hero struct based on the data we pass in. And we can say no hero if it doesn't work out. So basically we are decoding using the struct from our shared package. And I'm always forgetting the let. You will notice that in my YouTube videos as well. Missing out on that. And then we can say self-label text equal hero.name. But since we are in a background thread, we will basically have to make sure we're on a main thread. And if we run that, now we have a, sorry? Oh, right, yeah, you're right, thanks. We have to execute that. So task resume to execute the task we defined when we click on the button and that function gets executed. Okay, if we click that, we see in the log something happened, but name is not assigned. So is anyone having already a guess? It's basically because of HTTP. iOS is not allowing HTTPS, right? It's a simple fix. It's just for this demo. You will not probably have to do that in, is that unlargeable? No. So what we just have to do is add a transport, exactly, app transport security settings. Was that the right one? And then allow arbitrary loads. So come on, add that. Allow arbitrary loads to yes. And that will allow us to do also HTTP requests. Uh-oh. And if we send that, we're receiving link. And so now we are using a shared package defined in a different project using GitHub, using SPM, of course, with 2 scripts, but still we are using GitHub for iOS and server-side Swift to like reduce code duplication, bugs, and inconsistency in code. So it works. Yes, we can use SPM in order to use a shared package. And the cool thing that I found out is if we, for example, change something in the shared package, which is this one, hero shared, we just have to, I can just show that for a second. Let's say API root changes to API root lists, right? And then we are going to our hero app dependencies and just say Swift update, Swift package update. Oh, wait, we haven't pushed it. So we have changed something in the package. We are adding that. A new root. And defining a new, just making it faster. So we're pushing it, making a new tag, having it on GitHub. And now we can just say Swift package update, pulling it the new version, and without closing or reopening or whatever, doing an Xcode, Xcode is not, like in dependencies, Xcode is not showing the new version, but on the file layer, it is actually having the new version in. So I think if you close and open Xcode again, it will just fix the group naming here. But you are basically able to now call or use that root. And if we now click on the button, it won't work because there is no hero, because that root is not defined, like not used on the backend, right? So that's something nice to just show off quickly how quick it can actually work. Same goes, of course, for that one. Let's just do that for completion's sake, to have it, to end that in a running state. So let's update our API that uses that link, that root definition. Come on, pull it. Let's see. Let's run it. Let's have our app. And it works again. So we have we have just changed something in the shared package. Cool. Yeah. I found that pretty interesting and awesome. You have to play around with that to see where are the boundaries right now. But I think the future of SPM is it will be super cool. It was just so much easier. Let's get back to the presentation. So yes, our enemy was basically in the beginning code duplication, like bug prone, like more bugs likeliness because of code duplication, as well as inconsistency. We have basically defeated it using SPM, right? So let's continue the story. And that is the end.